Fine, the simulation is completed right now, and you can see that almost all the equations of momentum have converged. I mean, they have reached to a level of 1e minus 6. That is a good thing. But unfortunately, the continuity equation has reached to a level of 1e minus 4. It wasn't moving below this. And you can see this graph over here. It is straight and constant. Okay. So the reason for this could be because of two inlets. Okay. So the continuity equation has to satisfy. I mean, the amount of mass entering must be equal to the amount of mass exiting the domain. And because of the presence of two inlets, the complexity got increased. And because we have used a low resolution mesh, the continuity is just oscillating constantly at this level. Nevertheless, I assume that the convergence is satisfied for this case. And now we can just analyze the result as of now and see what is the outcome. So I'll just go to graphics as of now and click on contours. Now I will be going to the velocity over here. The velocity magnitude is what I want to look at, but I need to create a surface. Okay, that will be a kind of plane in the center of cylindrical object or the pipe what we have. So I don't have any surface over here which will consider that to be as a plane, because outlet is exactly at the outlet position, out position. Then we have the wall. So then we have this inlet in x and y, right? So all these positions are not that much fruitful for us. We need to go to new surface and click on plane, and we can just name it as 1 2 3 or anything. I'll just write something, and I want the plane to be on the xy plane. Okay, so I'll just select xy over here, and I want the z to be 0 and click on create, close it. Now I'll just select this surface what I've created, compute, display. Now you can see if I'm aligning it to normal, this is how your velocity field of propane gas looks like. Okay, now just accept the fact that this is a coarser mesh. We haven't been bothered about the inflation layers as well. Okay, the bottom point over here, or the main objective, is to understand the concepts rather than uh, I mean, yeah, that is a good point. We have to consider y plus values, and we have to see that we are maintaining the inflation layers in such a way that the range of y plus lies between 30 to 300 if we are planning to use the wall functions. Okay, I accept that fact, but since this is a conceptual study, we can just ignore that as of now, and we can just understand what's happening over here, right? And once we are sure with the concept, then we can redo the simulation by maintaining the appropriate y plus values in all standards. So generally, whenever you're working with, whenever you're working in any research or any investigations, uh, you have to understand that the first simulation will not be the final simulation. I mean, the first simulation will be the first one out of plenty of simulations what you need to perform, because whenever you're considering any research concept, okay, the first and foremost thing is to perform simpler simulations, and trying to see what are the complexities involved in that simulation, right? Maybe with respect to the modeling part, with respect to the meshing part, or with respect to the physics setup part. Most importantly, people are confused with respect to the setup, right? And if you're very confident and good with the meshing and geometry, then you just need to focus on the setup and understand the background of this options what we are using. As I've discussed in the previous course, each of these options is having something in the background. Okay, the software is embedded and it is coded in a way that the selection of one option turns on an equation in the background. So you need to know what are the equations that will be related for your, or what will be the desired equations for your case, and based on that you need to consider those. Maybe temperature is required, then I need to turn on the energy equation, right? Clear? So that is how you can just turn on and off with respect to the selection of equations, right? And in our case, we haven't selected the energy equation, we have just ignored the energy equation. That means we cannot predict the temperature flow field in this domain, because the energy equation is not solved in the domain, right? Now you can see anyway, the flow is entering over here, a kind of mixing is happening, and it is just exiting from the outlet. Clear? That is what is the outcome from this simulation. And if you want to look at the, what do you call, vectors, you can just click on vector and select the surface, compute, save display, and I'll just align it to normal, and let me just zoom in. So you can see the velocity vectors. These are representing the magnitude and direction. Possible, like, can I try to, yeah. So you can see that the propane gas is moving from the left to the right, and also entering from the top, mixing with this bottom one, and it is just moving on as it is, right? So you can see it is just turning over here and just going on. Clear? So at this moment, I believe you have understood the simulation for two inlet and one outlet. Clear? Now at this video, I'll just stop over here, and in the next video we will be discussing about DPM, that is discrete phase model over here, which is present over here, the discrete phase model, and we will be performing some activity over here in this domain itself, and we will see what all we can investigate with respect to that. So let us just move to the next video.